Hello, today we present our capstone project, Conservation Paleobiology in Urban Los Angeles. Our group members are Alex, Hillary, Dylan, Limey, and Cynthia. Our client is the Brea Tar Pits and Natural History Museum of LA County. Our faculty advisor is Emily Lindsay, who is the La Brea Tar Pits Museum's curator. Our project is a case study within a research project out of the La Brea Tar Pits and Museum that uses conservation paleobiology applied to an urban setting. Conservation paleobiology is the use of paleontology for the restoration and conservation of ecosystems. Los Angeles has more than 100,000 years of plants and animals or biodiversity and ecosystem change history that can be leveraged to inform potential conservation strategies. With this in mind, we used past and present species data to create models of future distributions of biodiversity found throughout LA. These models look at how different species react to climate change and inform us which species have the potential to be brought into the rewilded portion of the LA River. From this knowledge, we hope our research will be applied towards other urban sustainable developments. We're also hoping to bring awareness to the ecosystems surrounding the LA River to the public. Our research questions are, in the face of climate change, how can data modeling and the fossil record of LA be used to inform conservation decisions along the LA River? Also, how can the fossil record of Los Angeles be used to connect the public with the historic ecosystems of LA? For our deliverables, we created models to predict species habitats under climate change, maps of past and present species within Los Angeles, different data visualizations of species occurrences, and an ArcGIS story map focused on the LA River. For our project, we created species distribution models. To create these models, we obtained two forms of data. Shown on the left is climatic data. An example is of annual mean temperature. The climatic data we used is especially designed to determine the likelihood of where species will be located. On the right is species occurrence data provided by an online database. When worked together, these two data sets are used to create a model in a program called Maxent. This is an example of a model that we created.
Zooming into our area of interest, Los Angeles County, we see the change in distribution for the native California red-legged frog. These distributions vary based on climate change scenarios. Blue indicates that there is a high likelihood a species will be located there, while red represents a low likelihood. On the left is the current distribution, and on the right are different future scenarios from worst to best case. Under the worst case scenario, the species has the largest decrease in distribution, while the best case scenario has the smallest decrease. Similarly to the California red-legged frog, we ran a distribution model for the western fence lizard. In this species case, the current distribution on the left side did not experience a large change in distribution under the worst case scenario as well as the best case scenario. The second deliverable is a data visualization, a cardinal map animation of species occurrences. This shows the number of times species have been recorded throughout history. This provides insight on how museum collections from about 100 years ago can provide deeper time records that take into account urbanization. This map shows a distribution of the California red-legged frog and the invasive American bullfrog. Towards the end of the map, there is a large influx of American bullfrog occurrences. With the expansion of suburban neighborhoods in Los Angeles, this species was able to adapt better to this ecosystem change. To answer our second research question, we planned on designing an exhibit at USC for public consumption. Due to the pandemic, we pivoted to an online format to showcase our deliverables and research in a way that connects the public with historic ecosystems of Los Angeles. This online format took the form of a story map, a platform that integrates narrative with cartography to easily communicate science with the public. Our story map spans the entirety of the LA River history while providing novel insights of present and future distributions of species around the river. For future teams, we would like them to put an emphasis on plant species, incorporate deeper time records in modeling, find ways to apply the data to other restoration projects, and communicate with urban planners. Thank you for listening, and please enjoy our small video on the LA River.
What do you imagine when you think of a river? What is a river supposed to look like? What is the significance of a river? This is our river. This is the Los Angeles River. This might not be what you imagined. The LA River cuts across Los Angeles County from the San Fernando Valley to Long Beach, running through downtown LA and neighborhoods such as Boyle Heights. It passes iconic sites like Dodger Stadium, Griffith Park, and Warner Brothers Studios. These places weren't always here though. For tens of thousands of years, the river supported an assortment of life such as mammoths and saber-toothed cats. Some waterfowl and amphibians alive during this prehistoric time can still be spotted at the river today. The first humans here, the Tongva, lived with the river for thousands of years, using it for travel, water, food, and raw materials. In 1769, the Spanish arrived, displacing native populations. They developed the Zanja Madre, the original aqueduct of Los Angeles. Flooding was a natural component of the river's history, but with increased development, it began to take lives and impact communities. Due to this threat, the city channelized the river in 1938. Today, we're touring the LA River. Our visit is to the Lewis McAdams Riverfront Park in Elysian Valley.
The work for the river is a way to help connect people to the nature that's here in LA through this amazing space. And we're going to help introduce you to it today.
Our docents, Leela and Kat, lead us through the park and down to the riverbed.
And so that's where I'm really hoping that we get very ambitious with our plans and we start to really use sites like this to integrate that concept of bringing ecology back in these natural processes, allowing the river to actually go into those parcels, allowing the native ecology to come back, but at the same time really connecting, the local Angelinos, as well as then even having it a destination that people like really specifically come to Los Angeles to see, because it's this great case study of how we can kind of live in amongst nature in the middle of a city.
Moving to Southern California in a very city-like and urban place, it changed my mind on what nature could be.
I'm excited to see how our project can kind of come alive, just because we talk about the LA River so much throughout our project, but I've never even been. I didn't even know we really had an LA River until we started this project, and I was like, oh wow, there's a lot of history here.
And I think having a green space for individuals to go to just kind of get away, relax, cleanse themselves is really, really important. So I think that's one of the coolest parts about the LA River in the context of reclamation and rewilding projects.
Whether it's ugly or beautiful, poisoned and imprisoned, or flooding fresh and free, the Los Angeles River will always flow.